Hello. Back once more for another session of live coding. I feel like the schedule that the time when I start has been a little bit wonky because I'm still trying to settle on a specific time to begin. At first, I thought I would, when I came back from my little break, I thought I would start around 9 o'clock in the evenings. And then maybe I thought, well, maybe around 8 o'clock in the evenings. And then maybe I thought, and I was also thinking, hey, maybe I'll stream every day. And now here I am at 5 o'clock. Yeah, I don't know. I don't know when I'm going to do all the streaming and stuff, and whether it'll be every day or every other day or twice a week. I just don't know. We'll just say whenever I do it. But yeah, today I want to continue working in X11. The previous stream, I guess I could just show my progress. So the previous stream, I have created I created a program that will write to a file a pixmap. So we don't rerun that, and we can view this image. Error opening X display. But I'm on an X display. Maybe I need to let's do that. Okay, here we go. So yeah, So you can see that's the image. Yeah, okay. I was just making sure. Anyway, and then another program on stream before that one was just playing around with X11, and specifically hold on. Why is this? So it just creates a window, but I'm not sure why the window is like this. Maybe I need to do float. Yeah, okay, float. Yeah. So yeah, the dimensions are not as big as that. They're right. Those are the default dimensions. And if I look here, the dimensions are just 1024768, and my current dimensions are something like this: 3840 by 2160. So yeah. All right. So what I want to do is sort of marry the two together and start drawing actual pixel maps to X11. So yeah, let's get started on that. I think I'll just work right here, in this program, so I don't have to like go and create a new one. So let's see. The first thing I need to do is so the first thing I need to do is look up default GC, and that's like I need a graphical context, because so this returns the default graphical context for the root window of the specified screen, and the reason I need that is I think when I do xput image, I need a graphical context here. So I also need to x create image. And this basically, what does this do? X create image allocates the memory needed for an X image structure for the specified display, but does not allocate space for the image itself. Rather, it initializes the structure, byte order, bit order, and bitmap unit values from the display and returns a pointer to the X image structure. Do I need that? So what's the difference between X init image and X create image? Phew. me see. X in. Interesting. Okay. So let's say X image. So here is the image itself, or the structure of the image. Okay. And then we can say so let's declare what is that? I32 bitmap padding and bytes per line. Maybe I don't need that though. Well, I'll just do bytes per line equals 0. Right, okay. And then I can say, we'll just say, M arena push. And then size is image size. And we haven't actually defined that, so we'll define that now. We'll say I32, I64, U64, image size equals, and we'll just do the height and width of the window here. And then we'll say 4. Say pad equals 4. So this equals bitmap padding times 8. Guess? I'm not sure, actually. No, probably not. I think, yeah, this is probably fine. Implicit conversion changes signedness to unsignedness. All right. So we have the image size. And we can say image equals. Yeah. Okay. And then no. Sorry. Yeah. We need to say buffer U8 image buffer. I think. Yeah. Image buffer. All right. So now that I have that, I can say so I've got the image buffer here. Now I can do image equals x create image, and then pass in the display. And then what do I pass in here? The visual and the depth. Not really sure what that is, so I'll just pass in null for now. And then I need to pass in the pix format. Yeah, the format. And I'm not sure which format I need exactly. But yeah, I'll do zpixmap for now. And then next is the offset. Specifies the number of pixels to ignore at the beginning of the scan line. So I guess 0. And then we pass in the image buffer. And then we pass in width and height. And after width and height, we pass in the bitmap padding. And then we pass in bytes per line. Specifies the number of bytes in the client image between the start of one scan line and the start of the next. If the bytes per line member is 0, image will assume the image data is contiguous in memory and set the bytes per line to an appropriate value based on the other members. All right, I'll just set that to 0 then. Yeah. So that is set to 0. All right, so we've got our image. And now we also need a graphical context. What's the screen? Maybe I'll put this up here where all this other stuff is. Okay. So okay, so these are just some warnings. Yeah. Okay. I might be assigning too much memory. Not enough memory, rather. So, I probably need to go into this arena here and give more memory, like a way more memory. Let's just do 4 megabytes. Okay, cool. No issues there. So I guess I need to start worrying about whatever this visual stuff is. So let's look that up. XVisualInfo. Get it. Visual info returns a list of visual structures that have attributes equal to the attributes specified by the info template. XMatchVisualInfo function returns the visual information for a visual that matches the specified depth and class for a screen. Okay, let's just try it, I guess. So I need to do something like, let's say I32. Depth. We'll say 24. The depth specifies the depth of the screen. So can I look at that here on my X-render? I guess not. Maybe, I don't know. Matches the specified depth and class. Well, we'll go with 24 for now. And let's say XVisualInfo. We'll say visual info. Use of undeclared. What am I doing wrong here? This is an xlib, so why does it say you don't know where it is? XVisual. This is a type def struct. What's going on? Maybe I need to do this. Let's see. X match visual. So this is xlib. Well, let's go to user x include XMatchVisualInfo. Okay. So vim X11 xutil.h. Here it is. This file is xutil. I guess I need to include that. All right. Alrighty. Now, so I've got that. And I've got my default screen and my root window. Now I can say if let's go back here to man XVisualInfo. So if I do match visual info, this is a status. Let's see what I get. XMatchVisualInfo. So status returns. Oh, it's just an int. Okay, so why doesn't it tell me return? Returns if the visual is found. This function returns non-zero and the information is on the visual to VF info return. Otherwise, then a visual is not found. Match returns 0. Okay, so that's what I figured. If not 0, we'll say Cool. I mean, cool. So then we pass in this display, the screen. What else? The depth. Depth. And the VInfo mask. VInfo mask specifies the visual mask value. So I guess this stuff in depth mask. So visual no mask, ID mask, screen mask, depth mask, class mask, red mask, green mask, blue mask, all mask. I don't know. What is this? We'll just put in 0 for now. And then the address of the visual info. Class. Why are you not more helpful? Why? I think something like that is true color. Display classes used in opening connection. Note that the statically allocated ones are even numbered and the dynamically changeable ones are odd numbered. Okay. This is what I'm reading right here, so. Okay, I'm not actually using this visual info for now. I should probably return here. So we'll just return here and return and return here. And then at the end, we can return exit success. Cool. Okay, so now that we have the visual information, and then we can replace this to create an XCreate window, which takes a display window and then all this other stuff. XCreate window. So display and then the window parent and the X and Y value and the width, height, border width, depth, class, visual. All right, I think I can pass those in. So display, and then the root window, the X and Y value, the width and height, the border width. We've got the border width. And then I don't think we need anything else here. Border width. Yeah. Okay. And then here we can pass in the visual info dot depth. And then the class. I'm not really sure what the class is. specifies the created Windows class. You can pass input, output, input only, copy from parent. We'll say input, output. And then the visual, which we can get from the VisualInfo dot visual. And then the attribute mask. And so the attribute mask, or this value mask, specifies which window attributes are defined in the attributes argument. This mask is the bitwise inclusive or the value attributes mask bits. What is that? Oh, here we go. Here are the masks. So, yeah, okay. Not really sure what these do. CW back. You're not going to tell me what this does? Okay. All right. What is this? No information. I probably have to look up the manual page. This is dumb. X set window attributes. Placed on top of the stacking order in respect to siblings. Ooh. All right, I think I've got it. Something I need to look up is man x create color map. Okay. So XCreateColorMap function creates a color map of the specified visual type for the screen on which the specified window resides and returns the color map ID associated with it. Note that the specified window is only used to determine the screen. All right. So let's create a color map here. And we need this structure. And we'll pass this into the window. Okay, and then probably don't need this anymore. So so here we can say so here are all the things we could set. So got background pixel equals background. And then what else did I do? Border width. X creates simple window border. Right, the border. Right. I don't really care about border. I do want a blue background, just so I know I didn't mess things up. And then, well, let's create the color map. X create color map. We pass in the display, the window, the visual, and the alloc. Okay. Let's see. Display, the root window, the visual info dot visual, and we'll say alloc none. And we'll say here we're passing in CW background pixel and CW color map. Okay, invalid color map parameter. Bad color. Oh, I didn't pass. Did I pass in the color map? Did I set the color map? I did not. Okay, here we go. Cool. I can't tell if there's a border here. I guess not, because I set the border with 0. Well, what happens if I set it to like 5 or something? It's the same. You know, this might be being overridden by my window manager or DWM, so I won't put too much stock in this right now. So, specifies which window attributes are defined in the attributes argument. Right. So I did define the back pixel and the color map for sure. So let me just put that information attribute mask. I32 attribute mask. Oh, this is unsigned, so I need to change that to unsigned. Yeah. Let me change this a little bit. Okay, yeah. Okay. Now I have it. Now that I have the visual info, let me go back here. Let's see. Okay. Right. So I've got my X image. And I can pass in the visual info. I'm pretty sure that's it. Man, X create image. Right, the visual. And I can also pass in the depth. Let's go ahead and then depth format, which is zpixmap, and then the offset. The depth is unsigned int. Well, this is a signed int. Okay. Okay. Let's call this, let's just say, just so I have this and I know what it is and it's not unclear. It's not vague. Okay. And then, so I've got I have my graphical context. I have my buffer, my image. So I guess I can say, we'll say this is where we draw stuff. This is event stuff. So, let's, I want to copy this for loop. Yeah. Well, do I already have Y, X, and Y? Yes, I do. So I'm going to have to do something. Well, I can still copy this. So we'll just say this is I and J. Okay. Now, let's see how I'm drawing here. Pixel color set. bitmap padding. There might be a bug in mine. Right, yeah. Yeah, I got this wrong. Specifies the quantum of a scan line. In other words, the start of one scan line is separated in client memory from the start of the next scan line by an integer multiple of this many bits. And I think I wanted 32. And so I need okay. And then when I allocated the memory for that, where's the image size? Right, here we go. Okay. And then let's see, bitmap padding. Yep, that's correct. And then okay. So when I'm drawing, um I'll just add this. Although since it's 32 bytes, I might need another byte here. Maybe it's the alpha channel. I don't know. And then I need to set the color. I need to set the color. All right, still blue. Let's change this to window height. And then okay. Cool. So how do I do this? Because this uses 24 bytes. Sorry, 24 bits. Not 24 bytes, 24 bits. And I need to use 32 bits. So I guess for starters, we'll say we want the row. We'll go here and we'll say U8 pointer equals so this is the pointer to the image buffer. So we'll say image buffer plus y times width times bitmap pixel. Oh, I also need to add plus x times bitmap pixel. Use of undefined. I could take, hold on. Bitmap pixel. What's X? Y times width times. All right, seems good to me. So I've got the position of the pixel, and we'll say we'll just copy these. Okay, and then so I've got the float values, and then I've got the position on the pointer to the color, and then I can just set that. So I can say P. No, I need to get the pixel. Yeah. Okay, I've got, and then I just set 0. What is it? Equals color dot B. Okay, that looks correct. Conversion changes signedness. Okay. Where is that happening? 165. Right, so this is unsigned. And that is signed. Okay. Okay, so I'm not putting the image anywhere, so I need to do that. man X put image display drawable. I don't know what drawable means. Specifies the drawable. Yeah, I guess that means the window. It's just an X ID. All right, so yeah, window will work. And then what's returned? X put image function combines an image with a rectangle to specify drawable. What is returned? X. What does this int mean? Oh boy. Okay. Oh well, whatever. I guess I'll just won't do error checking on that. Image and then the X, Y. Specify the X and Y coordinates, which are relative to the origin. So I needed to find those. Yeah, okay. Int source, I'll just say 0, 0, 0. And then the image width, image height. That didn't do what I wanted it to do. So it takes a display and then the window and the graphical context and then the image. Okay. Not really sure what's going on here. Well, for now, let's just say, let me see. If this is 0 plus 0, this is 0. Oh. Maybe I need to flush stuff. No. I mean, I'll try it. Right, okay, I don't need to flush that, okay. Right, that didn't do anything. All right, for now, I'm going to let's put white here. Or maybe I'll change this to black. That's not what I want. Okay, what am I missing here? Image. That is an X image pointer. Display drawable graphical context image. Source X, source Y, dest X, dest Y. X create image. I am passing in the data. Image buffer plus image buffer. So I've got, this is the 0 position or the address. And then, sorry, I'm not speaking directly into the mic for some reason. So we've got this, the address of the image buffer. And then we've got bitmap pixel. Right. Okay. And then, so that's plus. Let's just do this one by one. Y times width times bitmap pixel. So so whatever the Y value is times the width of the image times the number of bytes per pixel. Yeah. Maybe I should do that. Bytes per pixel. Bits per pixel. So, and then I have that. Plus X times bytes per pixel. Sorry. Image width. Implicit conversion changes. Okay. I mean, it's definitely doing something, right? I guess I'll just breakpoint at 173. It's not getting there. Oops. All right, what's going on here? Why is it not getting this event? I guess time to include standard IO.h because I don't want to mess around with the buffer stuff here. I just want a quick printf. Oh, interesting. Oh. Is it because it's breaking on this? It should be breaking, right? Huh. Oh, you know what? I think I messed up. I'm supposed to have a sort of event loop, and I don't have an event loop. So that's my bad. I'm surprised it's been working this entire time. So then I do another while loop while what's up with that little flicker? It's weird, right? like it's not really. Like it's taking a while. Let's, I guess. Let's just try to, and then the U8 buffer. Yeah, we'll just say image buffer. Type specifier missing. Defaults. Ah. There we go. And then right. Okay, so then we just yoink this. Okay. And then we can just say something like that. And then it should just be there. No. It took a while. I guess I need to put the image immediately. Let's try that. That didn't work. Whatever. What? What? Why is it doing it immediately now? Oh, okay, I didn't do it immediately. I guess it's... There's just some things I need to figure out. I don't know. Oh, hello, sweet chestnut 07. How are you doing today? I didn't see you there because I was kind of distracted. Can I change this at all? What happens if I change that? Nothing. Huh. I'm not really sure. Whoopsie. I'm not really sure what's going on there, but whatever. What happens if I change that to 0? Ah, okay. Right. I think I remember this from the last stream. And now I can change this out. U32 bytes per pixel. Remove this. Cool. Can I do something interesting here with it? Maybe I could say like pass in I32 or U32 bound offset. And then we'll say, and then what do I want to do here? So we'll say U32 offset equals 0. We'll say count. And then here we'll pass in count. And then we'll say count plus plus. And then what do I want to do with this here? I guess I could say count. But this is a float, so I need to do something. And then we can say count equals count modulo 255, so that it sort of loops through 0 through 255, we'll say. And then we'll do F32 offset divided by 255. And you can kind of see it changing. You can see the color changing as time passes. But I'd like to make it even a little bit more complicated than that. So we'll change it so that so B8 increment equals true. If increment else and then if count equals 255, then we'll say increment equals false. And then if count equals 0, we'll say increment true. And now you can see it's growing a little bit more blue, a little bit more blue, a little bit more blue, a little bit more blue. And then it's just going back down gradually till it's more red, more red, more red. I think that's a pretty cool effect. What do you think, Sweet Chestnut 00? Sweet Chestnut 07? What do you think? All right. All right. I'm pretty happy with where I got today. So, yeah, let's go ahead and add all this stuff. And all right. I guess that's it. Doesn't seem like a lot, but I'm pretty happy. And maybe next time I'll actually read a file and copy that buffer to X11. So if you're interested in this kind of thing and want to watch me live code my way through a C code base and learn more with me about graphical applications and graphical programming and other stuff, I have other things I'd like to explore, like sound, like wave files. So playing sounds or playing sound files. And then who knows where I'll go after that. Sky's the limit, I suppose. But if you had fun, I hope you had fun. I mean, I had fun as well doing this stuff. It's a little tricky to figure out, especially since the documentation for X11 is kind of sparse. But that's the whole point of this series on this streaming series that I'm doing, on this live coding series that I'm doing, is to figure it out, muddle my way through, and then see where I get. Anyway, I think that'll be all for now. Thanks for watching. Goodbye.